Hello class, this is Mr. Joseph, and this video is going to cover section 2.4 over complex numbers. So you should have these notes on your desk, and we're going to go ahead and get started. And we will start by looking at this equation, y equals x squared plus 1. This equation, y is a function of x, and I'm going to ask you to find the zeros of this function. To do that, we would set y equal to 0. Solve for x, so I'm going to go ahead and switch sides here. Put x squared over here. On the other side would be a negative 1. If we want to solve for x, we can take the square root of both sides. And as Billy pointed out in class the other day, the square root of x squared technically is absolute value of x. And if we want to remove the absolute value signs and just have x equals here, we're going to need to take the positive and negative of this side here. So plus or minus square root of negative 1. Now the square root of negative 1 is not a real number because there's no real number that when you square it, it will equal negative 1. Because if it was positive, the two squaring it would be positive. If it was negative, squaring it would also be positive. Another way to look at this is if we look at it graphically, and I graph this function. Remember, it's like the parabola y equals x squared that normally has a vertex at 0, 0. We're just giving it a vertical shift of 1. So that's 1. If I had asked you to find the real zeros of this function, that would be equivalent to asking you to find the x-intercepts. And as you can see from this little sketch, the graph of this function has no real zeros because it doesn't have any x-intercepts. It does have zeros, though. They just happen not to be real. They're what we call imaginary. And they don't show up on the x-axis because as intercepts on the x-axis because the x-axis is a real number line, and these are not real numbers. And the way that people decided to deal with these is to give this value a name, and they named it I, standing for imaginary, and square root of negative 1 they call the imaginary unit. And we're going to base all other imaginary numbers on this imaginary unit. And so, for instance, I could take another imaginary number, such as the square root of negative 7. This is not a real number. But I can rewrite this as the square root of 7 times the square root of negative 1. Split it up like that. Square root of 7 is a real number. It's an irrational number, but it is real. I can think of this as square root of 7 times I. So in a sense, I've kind of quarantined the imaginary aspect of this number all in this I. So I can think of any imaginary number, like square root of negative 7, as a real number multiple of this imaginary unit I. And that's what the notes, if you flip back to the notes, that's what they're saying here. If A is a positive real number, then the square root of negative A is an imaginary number. And I can write that square root of negative A as I times the square root of A, some real number multiple of I. Okay.